I'm also Nancy Shackle and Phil Grayson are sort of co-authors on this today. There are lots of other people who've contributed to this over the years. I see Andrew Cogswell on the meeting today. He's contributed significantly to this work as well. And so this is just going to be a very brief overview of what we've been doing for the last few years with Small Craft Harbours sector and DFO nationally. Just a bit of context here. In 2019, the Council of Canadian Academies released a report called Canada's Top Climate Change Risks, where they looked at 12 major risk areas for climate change from a national perspective in Canada over a 20-year time horizon. And the top 6 areas that they identified for climate change risk were physical infrastructure, coastal communities, human health and wellness, ecosystems, fisheries, and northern communities. Well, you know, a lot of those really fall within areas of DFO mandate. So it's critical, I think, that the department continues to advance efforts on how we address climate change in these areas. Also in 2019, the IPCC released a special report on the ocean and cryosphere in a changing climate, where they updated some of their assessments from the earlier assessment report 5, which was released in 2013. And here's just one figure from the summary for policymakers from that report. Basically, what it shows here is there are 2 primary drivers for sea level rise globally. The first being changes in ocean heat content. As we warm the global ocean, that water expands and therefore creates global sea level rise. But also as we heat the Earth system, we're losing mass from the Greenland and Antarctic ice sheets and also land-based glaciers. So those are the 2 primary things that are driving global sea level rise. And if we look at for the year 2100, we see that the blue line in this lower panel is a sort of a low emission scenario, and the red is a high emission scenario. And what the median values of those for 2100 is about 43 centimeters in the low case or 84 centimeters in the high case. And so what that indicates to us is regardless of what emission scenario we follow through the coming century, globally we're going to experience sea level rise, and it's a matter of how much we're going to experience and not whether it's going to occur or not. It's a bit more complicated when you get down to the regional level. What I'm showing here is national sea level projections for Canada. Now, what happens is when you take that global picture and then you superimpose vertical crustal motion at the coastline, you'll find that in areas of Canada, there are areas where sea level is going to rise over the coming century, and those are indicated by the red areas here. And actually, there are some areas that are going to rise faster than the global average, those dark red areas, and specifically in Atlantic Canada here, that's one of the areas where we're going to experience relatively fast sea level rise at our coastline. But there are areas in the Hudson Bay and Eastern Arctic where even under a high emission scenario, they're going to experience at their coastline sea level fall because the vertical land motion in those areas is actually faster than global sea level rise. And this data is now all available for various emission scenarios on climatedata.ca. And there's also a technical report by Tom James at NRCan that was published this year that summarizes that data. So if you're interested in relative sea level change at various areas of Canada, you can go to climatedata.ca. So the point from this slide is really when you're planning for sea level change along Canada's coastline, you really have to be aware of this regional variability. Another report that came out in 2019 was Canada's Changing Climate Report, and one of the headline statements from that report was that coastal flooding is expected to increase in many areas of Canada due to this local or relative sea level rise. So we have all of these context pieces of that, sea level change along Canada's coastline is certainly something that we have to be aware of over the coming century, and we will have to adapt to that depending on our location. In terms of DFO, we have a pretty significant investment in coastal infrastructure. This is a plot that Andrew created a number of years ago that shows all of the small craft harbor locations in Atlantic Canada, all those green dots. And the red dots are RPSS locations. So nationally, DFO Small Craft Harbours is responsible for maintaining about 1,000 of these commercial fishing harbors. And there's about over 700 of those are located in Atlantic Canada. So these harbors are composed of almost 7,000 pieces of infrastructure, and the estimated replacement cost of that infrastructure is about $4 billion. So there's a continuous need to upgrade and maintain this infrastructure over time, and decisions have to be made by small craft harbors about where to best invest their limited resources. Now, this is important because the majority of fish landings in Canada at a valued at about 1.6 billion annually occur at these small craft harbor locations. So it's very important to our fishing industry to maintain this coastal infrastructure in good working condition. So we started a few years ago a collaboration with small craft harbors and our economic analysis and statistics group in Ottawa, where we were trying to develop a vulnerability index for small craft harbors infrastructure to help managers in small craft harbors make decisions about where to invest their resources. So this vulnerability index is composed of three components. There's an exposure component to it, which is sort of natural forces like sea level rise or change in sea ice conditions. There's an infrastructure component to it, and also a socioeconomic component. Each of these components contains 3 to 5 variables that we tried to ensure are relatively independent. And each of these variables is scored on a scale of 1 to 5, where 1 is assessed as low vulnerability, and 5 is assessed as having a high vulnerability. There's an intranet site for our small craft harbors managers where they can explore the results of this assessment of the index. And you can see on the right-hand side here what goes into each of these components of the vulnerability assessment. So, for example, under the infrastructure subindex, there's something we call a degree of protection. That's an assessment done by engineers for every small craft harbor site. It's actually done for this project, where they assess whether the infrastructure is in a sort of a protected location in a harbor versus, which would be a 1, versus something that's completely exposed to the ocean, that would be assessed as a 5. Total replacement cost gives us an assessment of how expensive it would be to replace that infrastructure at that location. And harbor condition is something that the engineering team in small craft harbors assesses for all of their sites as well, with a 1 indicating that the condition of the infrastructure is good in that location, and 5 would be in poor condition. In terms of socioeconomics, we look at population of the community serviced by that small craft harbor facility, the percent income derived from fishing to give us an idea of how dependent the community is on fishing, and the quantity caught per vessel to give us an indication of how active that facility is in terms of landings. Then we took that 1 step further, and this is where Nancy's involvement came in, where we combined both this coastal vulnerability index for infrastructure with a lobster vulnerability index, where Nancy and her group looked at how changing climate could impact the lobster fishery in the Maritimes region through looking at gain or loss of offshore thermal habitat as the bottom temperature changes. And we used future model projections, 2 different models to assess that change in habitat. And then also combine that with the stock status for lobster. And you can see on the right-hand side here, there's just a pie chart that Bill Grayson had made up for each of the lobster fishing areas, LFAs. The LFA numbers indicated in that plot, but also the pie chart shows you the total lobster landings in the sort of beige or tan color. There's also a green for total snow crab landings, which are some of the eastern areas is relatively important. And then total landings of all other species in that pie chart is indicated in blue. And of course, the size of the pie chart indicates the total income from landings in those areas. So you can see that of course, in Southwest Nova, that lobster, of course, is extremely important to the fishing communities there, and brings in a large amount of income. So the panel on the bottom here, basically, we're trying to combine and visualize both the infrastructure index and the lobster vulnerability index. So you're seeing for each of the LFAs here, the LFA numbers indicated in the box along the top. So it goes from 38, which is in the Bay of Fundy, 35, 36 again, Bay of Fundy, and then 34 and 33 in Southwest Nova, and then up towards the eastern shore. So you can see that, if we look at the red box and whisker plot, that all of these areas are relatively dependent on fishing, so it's important to these communities, and that therefore they are vulnerable to changes in the fishing industry. And in areas 35 and 36, the shading indicates the lobster vulnerability index. So the darker the color, the higher the vulnerability. So those areas were assessed as being more highly vulnerable. And we actually don't have data on the offshore lobster industry for the LFAs on the right-hand side of that plot. So the background of those is white at this point. So what we're doing currently is considering, when the IPCC Assessment Report 5 projections are and information is released, we'll be looking at updating some of the information in the vulnerability index. Bill and Nancy and I have been looking at trying to improve the economic indicators to better reflect the coastal communities that we're looking at in this index, because we've found some areas that I think we can improve upon in what was done previously. And we're also looking to extend our effort by integrating other fish species response to climate change into a vulnerability index that expands beyond just the lobster industry. And that's the end of my presentation.